So today, we're going to focus in specifically on the ambiguous case of the law of signs. Okay? And there is an ambiguous case. Okay? So ambiguous means that it's open to more than one meaning. For instance, a bat or a bat. Okay? When you just say a bat, it's open to multiple different meanings. Okay? So we're going to do that. Today is that. Tomorrow is going to be a practice type of a day using law of sines, law of cosines type of practice. We'll have a worksheet, and we just developed this worksheet this week, so it's not in anybody's packet. It's not in the green packet. So in-person people, you'll get yours tomorrow in class. Out of school people, you'll have to go on It's Learning and grab and use yours. But you don't have to have the actual physical worksheet because it's literally just 3 parts of a triangle listed kind of a deal. Okay? And so it's not like it's this elaborate picture of a triangle and all that stuff. And it's just literally 3 parts of a triangle listed, and I think there's like 10 problems. So, okay? And you can do that on anywhere. I do believe that we are going to be collecting that one, but don't quote me on that one. I'll find out for sure on that one, and then I'll send out a messenger about that. Okay? And then Friday is some more practice for you, and there will be a formative this week. It'll be a brief formative, and then so you need to get that formative done prior to Monday. Okay? All right. On top of that, we still have some people here in this room, here in this Google Meet, that have to finish last week's summative. So if you are one of those that have to finish last week's summative, please make sure that you get that done as soon as possible. Okay? So please do that as soon as possible. Okay? All right, here we go. So the law of sines from yesterday. Okay? I don't know why we canceled out the law of. There it is. Oops. Oh, come on now. There we go. So the law of sines is that. We learned that. You learned that actually back in geometry. Okay? Law of sines is sine of any angle is proportional to the side length within any triangle. Okay? Doesn't have to be a right triangle. That's the cool part about it. Okay? So, the ambiguous case, the build-up for it. How many, refresh my memory, how many different ways can you prove, now this is a geometry type question, how many different ways can you prove that a triangle is congruent? Thinking back. When you were doing proofs in geometry, I know this was a couple of years ago, when you were doing proofs in geometry, how many different ways, or give me a way. Side angle side is one way. Give me another way. Side, side, side is another way. Give me another one. Those are the 2 most common ones. Anybody at home got a way to prove 2 triangles are congruent? Let's. Angle side angle. Okay? So there's side, 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 side angle, side, which we got. Angle, side, angle, which we got. Angle, angle, side is another way of doing it. Okay? And then the last one really doesn't apply for us, but that's hypotenuse leg. Okay? And that only works in right triangles. So that's why we don't necessarily use that one. Okay? But so we got those four. Now those four are important for you because when you're solving a triangle, we use much the same classifications. Okay? So if we are solving a triangle and we're using side, 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 that is the law of cosines. Okay? That's the one that we did yesterday, where we find the biggest angle first using the law of cosines, then we find the smallest angle using the law of sines, then we find the third angle using the triangle sum theorem. Okay? Side angle side, that is also a law of cosines. Because you have two sides and the angle in between them, that's how the law of cosines is set up. To find that opposite side of the angle, then we can use law of sines to find another angle, and then we can use triangle sum theorem to find the third angle. Okay? Angle side angle, this is a law of sines type of problem. Because we can use the triangle sum theorem to find the third missing angle, and then we have that complete fraction. Likewise with angle, angle, side. This is the law of sines case. Because we can find that third angle using the triangle sum theorem. Then we have a complete fraction, and we can find the two missing sides. Okay? So those are the easy ones, because those all only produce one triangle. Okay? So that leaves the naughty one left. Okay? Now, you were probably told back when you were in geometry that you can't prove a triangle using your hind quarter, okay? Using your butt. Okay? And that's true when proving two triangles are congruent. When you're solving a triangle, the angle side, your hind quarter, if you will, is the one that produces the ambiguous case. Okay? So, what I would like you to do is, I would like you to find me angle B in that triangle. Okay? Find me angle B in that triangle. Any takers? What do we get for angle B? Or what did you get, I should say, for angle B? 64.78 degrees. Yes? Here's the problem. What did I get last night? 115. 217 degrees. And I checked it, and it worked out. Because what I did then is I said the sine of 20.5 degrees divided by 12, and I said, well, what's the sine of 115.217 degrees divided by 31? And so then let's check this one too. Okay, so let's check those. Check all of those. You check. So you three over here, check the middle one, mine. You three fellas, check the red one, and I'll check the original one. Sine. Did everybody get 0.029183948? When you did it? Kylie, you're looking at me like you didn't get that. Last few didn't? Okay, that was a rounding thing. Yep, that's a rounding thing. But the first, like 5 or 6, yes? Okay, yeah. Or something close to that because of, depends on where you round it. Yeah. Ruh-roh. One might even say, ruh-roh. Okay, so this is where the ambiguous case comes in. Okay? Again, the definition of ambiguous is it's open to more than one interpretation, open to more than one definition. Okay? So the ambiguous case only happens when you are given the angle, the side, and the side. Okay? It's the easy way to remember it. If you see an ass, it's ambiguous. Okay? Okay? So if you have the angle, side, side case, it is the ambiguous case only. Okay? So the first condition is we look off of the obtuse angle. Okay? Now these are going to be, we're going to have a bunch of different scenarios here. Okay? And so you're going to have to write most of these down. Okay? So if I'm given an obtuse angle, oops, I missed. So if I'm given an obtuse angle, much like this, close enough. Okay? So here would be my given angle. Then my side would be there and there, or the other way too. We could have had, you could have there, your side could either be down here, or it could be over there. Okay? Doesn't matter which way around the triangle you go. Okay? It's still an angle side case. So, if the opposite side is bigger than the adjacent side. So this would be the opposite. This would be the adjacent. If that's the case, then one triangle. Okay, so if that's the case, only one triangle. Write it down. This is what today is. Okay, right? What?
What do you mean by only one triangle?
So we can have, so what's going to happen is we're going to, the angle side case, we're either going to have 0 triangles formed, 1 triangle formed, or 2 triangles formed. Okay? So in this particular case, we're only going to have 1 triangle formed, and we're going to use the law of sines, and we're going to solve it, and we're going to be done with our labs. we're going to move on to the next problem. Okay? Same scenario. There's my angle. There's my two sides. But now my opposite side is less than my adjacent side. That's going to give me no triangle formed. Okay. And you'll know which one's the opposite side because it will have the lowercase letter of your angle. Okay? You'll have that complete fraction that we were looking for yesterday in the law of sines. But you'll only be given one angle, so you won't be able to continue with it. Okay? So that is the obtuse angle. If the given angle is acute, and the opposite side is longer than the adjacent side, we have only one triangle formed. And again, we use the law of sines to solve it. Okay? But then down here, this is where we get into it now. When the adjacent side is longer than the opposite side. And the reason, the reason that we can get into it here is because, now I gotta get this all get ready to go. Come on now. There it is. Okay. If I could have one triangle, if it works out and it becomes a right triangle, and that's pretty cool. Okay. I could have no triangle formed there. Or if it's just long enough, I could have one triangle formed like that and one triangle formed like that. So it would form two triangles. Okay. So we have to figure out where that comes from. Okay. So this, stop touching things. Okay. So this is the true ambiguous case. Okay. So again, we would have been given an angle, a side, and then this red side in here. Okay. So that's what we're looking at right now. So if and then this right here, this is the height of my triangle. And that is going to determine what happens. So if, ay caramba, I should have went through and proofed this sucker beforehand. Come on now. So if the opposite side is equal to the height. I almost said hypotenuse. So if my opposite side, so this is the opposite side here, is the red side. Put that in red all the way through, because then it'll be the same all the way through. Okay? So if the opposite side is equal to the the height of the triangle, you get one right triangle. And you don't even have to use the law of sines then. You could use SOHCAHTOA, you could use Pythagorean theorem, you could use triangle sum theorem to do that. You wouldn't have to use law of sines. You can, but you wouldn't have to. Okay? If that red side is smaller than the height, so that would be, so the first case scenario would have looked like that. And that would have been this scenario number 1. Scenario number 2 says that, whoa, come on. Well, that if it's shorter than h, see how it doesn't flap, it never hits that other side, or this bottom part here, never hits it, so no triangle is formed. Yeah. It's this other one. It's this last one. That's the biggest. Okay? Because here we get 2 triangles. Because if it's longer, now we'll see if this works out for me. Because if it's longer, come on. I want this to work for me now. So frustrating. If it's longer, well, right, so alrighty. If it's longer, we get 1 triangle. We get an obtuse triangle formed with a small missing side, and we get an acute triangle with a large missing side. Okay? So we get 2 different ones there. So let's wrap it all up with the angle side-side case. You're really looking at whether the opposite is bigger or less than the adjacent. Okay? If it is, that's kind of not so clear. Clear that up a little bit. That's not so clear at all. Okay? So if the opposite is bigger than the adjacent side, we are always in a 1 triangle case. We're going to solve it with the law of sines. If we're in the opposite way, where the adjacent side is bigger, what you're going to do first is you are going to check. I shouldn't say check the height. Let's tweak that a little bit. Let's say instead, let's say, find the height of the triangle. Then we're going to compare it didn't pick up my pen enough. Then we're going to compare h to the opposite side. If the opposite side is bigger than h, 2. Equal, 1 right, smaller, no. Okay. Now that I've completely and utterly confused you, let's walk through a couple of these type of problems. All right, here we go. So, first thing, I would draw yourself a picture of a triangle. Okay? Just a regular old triangle. Doesn't even matter what it looks like. Then I would go through and I would label. Angle A is 42 degrees. Side A is 22. And then either one of the other two sides can be the 12. So since that's B, and that's going to be B, we'll call that C. I should put those in different colors. Okay. Is this an angle side-side case? Yes. Do we have an acute angle? Yes. Okay, so that's our first check. Our first check was it's an angle side-side case. So then it's an acute angle. So then we have to compare the opposite side to the adjacent side. Is the opposite side bigger or smaller than the adjacent side? Bigger. Okay. So that, if I go back one, opposite side, we're in an angle side-side case. Opposite side is bigger. One triangle is formed, correct? Okay. So only one triangle here. So that's what my triangle is going to look like. Solve it for me. Okay? So go on right now and solve that triangle for angle B, angle C, and side C. That's what I got. Agree all the way around? Okay. Love it. All right. Let's try this next one. Again, we want to draw ourselves a picture. Angle C here is 85 degrees. Side C is 15. Side A is 25. Are we in the angle side-side case? Yes? Do we have an acute angle? Yes or no? Yeah, because it's less than 90, right? So then we have to check opposite and adjacent. Which one is bigger? The adjacent side is bigger. So when we were in the acute angle case, with the adjacent side being bigger, what did we have to do? Go back 2 slides. Opposite side is bigger, right? Or excuse me, adjacent side is bigger, so we have to check the height, correct? Okay. So that's going to be our next one. Our next step then is we need to check the height. So I'm going to drop in, oops, that's a bad one. Why is it off? Suddenly. I don't know why it was off. Okay. So there's my height. It's a right angle. How can I find the height? Using the sine. I can use some SOHCAHTOA action there. So the sine of 85 degrees is equal to h over 25. So my height is equal to 25 times the sine of 85 degrees, which is 24.905. My opposite side is 15. My height is 24.905. Does that form a triangle?
No.
No, it does not. No triangle form. That opposite side doesn't reach down to hit that other side. So no triangle form on that one. Okay? Love it. Let's try this one. Again, draw yourself a triangle. Angle B now is 32 degrees. Side B is 5. Side A is 7. Okay. First, angle side side. Yay or nay? Yay. So what do we have to do? Check our angle. Acute. Yep. Okay. What do we have to check then? Opposite and adjacent. Which one's longer? The adjacent is longer, right? So that means we've got to check our height. Yep. So that's going to be the sine of 32 degrees is equal to h over 7. So it's this triangle right here. And it's a right triangle because we dropped the height. So it's 32 degrees there, it's 7 there, and it's h there. So I'm using SOHCAHTOA. Yep. Okay. So that is what? What do we got for 7 sines of 32?
3.709.
3.709. Opposite side less than the height? No. So that means there we have a triangle. Equal to the height? No. Longer than the height. So longer means 2 triangles. Okay, so this is a true ambiguous case. Okay? So here is how we go about solving the true ambiguous case. So we're going to take the first triangle first. We'll take the second triangle second. Okay? First triangle first, we solve it like normal. Okay, we solve it as is. So this would be then the sine of 32 degrees divided by 5 equals the sine of angle A divided by 7. Finding angle A. So that's going to be 5 sines of angle A equals 7 sines of 32. That's going to be the sine of angle A is 7 sines of 32 divided by 5. That's going to be angle A is the inverse sine of that. $47.892 degrees. Yes? Okay, love it. Then we're going to say that the missing angle, so that's angle C. I almost put angle B there. Couldn't remember. Angle C is going to be 180 degrees minus 32 degrees minus 47.892 degrees. So angle C is 100.108 degrees. Okay? And then finally, we would say that the sine of 32 degrees over, what was it, over 5?
Yeah.
Yep. Is equal to the sine of 100.108 degrees over side C. I'm going to extend the page again. C here is 5 times the sine of 100 all over 9.289. Yes? Okay, got it. Nodded. All right, so that's triangle. Whoops, that breaks. Where'd that go? That's triangle number 1. Okay? Now, we got to do triangle number 2. So how we find triangle number 2, so we should go back and we should put all of these are sub 1s. Because those are all up of the first triangle. Yeah? So triangle number 2. The first angle A sub 2, because we found angle A first, is always going to be 180 degrees minus angle A sub 1. Okay? So we're going to take whatever angle you found first in the first triangle, you find the supplement to it. 180 degrees minus that angle, that's your other angle. Okay? So in this particular case, it was 180 degrees minus 47.892 degrees. So angle A sub 2 is 132.108 degrees. Then you go through and you do the rest. So then that's what that one is. Angle, what do we find next? Angle C. Yep. So angle C sub 2 is going to be 180 degrees minus 32 degrees minus 132.108 degrees. That's going to give me 15.892 degrees. So those two are easy calculations. And then the third one, you're just going to follow this blue right here. So C is going to equal 5 times the sine of an angle divided by the sine of 32 degrees. And that angle is going to be angle C. It's this, right down here. It's that same pattern. Okay? So the second triangle you don't have to do very much work with because you've done all the work in the first triangle. And so you should get side C sub 2 here is 2.584. And there's your 6 answers to that. Yeah? Good times? Whoo! That's a lot to get through in an hour.